Good morning, 7th graders. Here we are Tuesday. You've got today and then 2 more days, and then you will be on your way to a 4-day weekend where you don't have to check Google Classrooms and you don't have to worry about all this online stuff and stare at a screen all day long. And actually, the nice thing is after today, the weather is supposed to get pretty nice for at least almost a week, with a couple of days in there. But I mean, weather in the 70s. We're up near the 70s with some sunshine will do us all quite a bit of good. And it's nice because when you look outside, you can see the leaves are turning green. Take notice of these things, these small things that we really should be grateful for. The leaves are turning green, grass is turning green. So it's spring and into summer has such a great feel. I sit and I watch hummingbirds and the bird feeder outside our window in our living room and orioles chirping. It's been good stuff. All right, so today there's a lot, and I apologize. It's going to be kind of hopefully not too boring for you, but I'm really trying to figure out a way to impress upon you the conduction idea, which of course is thermal energy transfer through direct contact. Listen to my words. It's energy that's transferred molecule to molecule through direct contact, things that are touching each other. So I'm going to attempt to explain this, but I also, you've got a couple of videos, and this is a real bummer for me. This is one of my favorite things because I love physics and I love the behavior of molecules based on energy. And we do a lot of really cool stuff in the classroom for this. So just be very diligent, be patient, listen well, and then you have one question to answer that's posted with this Google assignment that you can just answer and post. I might have you do in 2 places, but right now just be patient. All right. So again, energy, energy can be transferred molecule to molecule through direct contact, and that's called conduction. And of course, we know this candle here is providing thermal energy, and here's a metal rod. This is what it would look like in the classroom if we had done the lab there. Of course, I had a different metal rod in my video yesterday. And then rather than butter on the metal rod, these are like big nails, tacks or nails, and then they've stuck the tacks or the nails to the metal rod using wax. All right, so we all know what happens to wax when we apply heat. Wax turns from a solid to a liquid. So the idea here would be the same. They would start a timer. Put the metal rod under the candle, see the amount of time it takes for the heat to transfer down the metal rod through conduction, turn the wax into a liquid, and then that tack would drop, and then they'd hit the stopwatch or hit the lap button. And then they would see how long it would take for the next one. Wax melts, drops, heat continues to conduct down the metal rod, wax melts, tack drops, and keeps going to number 4, wax melts, tack drops. Now, the tricky thing is, one, depending on the type of metal rod you use, you could have really fast transfer. I had in school, the rods we use have really fast, they're very conductive. They have a lot of electrons in that metal, or free electrons floating around the metal. And then the rod I use in the garage must not have a lot of free electrons around those molecules. Oh, excuse me. Because it took a while. All right. And as that thermal energy is going to go down this rod, it's going to take longer between 1 and 2, and then longer between 2 and 3, and then longer between 3 and 4, because there's only so much energy being transferred from this flame. So if these are molecules colliding and pushing down the metal rod, that can only go, that energy can only be shared so far. Eventually, if the rod was way out here, you could probably have your hand on it and you'd never feel that thermal energy just because there's only so much energy that can transfer down there. And of course, we know that the rod is also transferring thermal energy, heat, to the air around it. So it's not like it's all staying in the metal rod. So it takes longer in between these because the collisions of molecules just aren't as powerful as you move down the rod as the energy is being shared. Okay, I want to show you another graphic. So here's a little bit more of a molecule version. Again, you're going to see this a number of times. Conduction is the heat transfer, or is the transfer of heat, thermal energy we'll call it, from one solid to another. It can be from solid to liquid, liquid to liquid, liquid to gas, things like that. When you heat a metal strip at one end, the heat travels to the other end. As you heat the metal, the particles vibrate, and they make the particles right next to them vibrate, and that keeps going. A little bit like dominoes, except for the energy is also being transferred to the air around the metal rod, so it can only go so far. So here you'd have where the candle is, you'd have your wax underneath here, or I'm sorry, your wax or butter in my case, and then we just heated that metal rod and it transferred down. But you can see as it goes, there's not going to be much vibration at the other end just because it can only go so far. Okay, so that's one part of that. Let me take you to another little thing. Here is a good example, and you're going to see in this video, because this is animated. So you can see in this video, this portion here is kind of a big deal. You can see how the molecules are vibrating from where the flame is and colliding and then moving down the line. Now this is a glass rod, and he's going to describe the difference between a glass rod and a metal rod. And the metal rod has all these free electrons floating around the molecules, and those free electrons definitely help the energy transfer from molecule to molecule. Okay, so real simple today, guys. Your job is to consider and think about thermal energy transfer. This is called conduction, so this is today's goal, conduction. And it is the transfer of energy through direct contact. You'll watch, you see the beginning of it. You'll watch this video, heat energy, and then you'll also watch this video. It just looks like this at the beginning, I think. There you go, just conduction as well. So you've got two videos. You're going to watch, well, you're watching my video with a little bit of an explanation of conduction. And then you're going to have two other videos to take care of. Okay. So when we go back to this guy, you'll see, one, we're still constructing an explanation. So you're going to answer, you're going to make a claim and provide evidence. Oh my gosh, excuse me. In a couple of days, you're watching my video, then you're watching the two YouTube, and then you're going to answer your own words. What is the energy transfer called conduction? What does that mean? And then turn it in. And then that'll more or less do it for today. Just a couple of videos. Again, we're still continuing energy transfer. So just be mindful of that. I think that's it for today. Turn in, you got to remember to answer the question associated with the assignment and turn that in. I think tomorrow we'll move on to something called convection, and we'll talk about that a little bit more. All right, guys. Well, have a great Tuesday, and I will see you tomorrow.